Hello students, in today's class we are going to learn about combinations. We are learning the chapter permutations and combinations. So far we have solved problems on permutations and basic multiplication principle, right? Permutation means what? The various arrangements. We will select the objects from the given number of objects. We will denote it by NPR, which means out of n objects taking r objects at a time, right? What is NPR? NPR is n factorial divided by n minus r factorial. So here we are going to learn about combinations. What is meant by combination and what is the difference between permutation and combination? In permutation, the order of the objects which we are choosing plays a vital role. When in combination, the order is not important. For example, permutation, the problems which we solved in permutation involves basically like framing the words, framing a digit numbers, right? When we talk about 3-digit number or 4-digit number, in which position the number lies plays a vital role, right? If the number digit 3 lies in the 100th place, will not be same if it lies in the 10th place. So in which place it lies plays a vital role. So in such case you have to go with only permutations. When the order of the object which you are choosing is important, you should go with permutation. But when it comes to combination, the order is not important. When you feel like to that particular situation, when the order changes also, it doesn't matter, then you should go with combination. A simple example is like the handshakes in a party. If you say there are 10 people in a party and mutually if they are shaking their hands, if person A shakes his hands with a person B is same as person B shaking his hands with person A, right? So if who is shaking his hands first is not going to play a major role here. In such a kind, we will go with combination. Hope you understood. When the order is not important, in which order the event occurs, when the which is not important, then we will go with combination. When the order plays a vital role to the particular situation, we will go with permutations, right? So let us derive the formula for combinations now. Again, the derivation of NCR is omitted from your 2021 syllabus. So you don't want to worry about the derivation. It is enough if you remember the formula. We have seen what is NPR. NPR means out of n objects taking r objects at a time under permutation. The same way we will denote under combination as NCR. Out of n objects taking r objects at a time, right? So NCR formula can be derived from this. We see NPR can be written as NCR into r factorial. What is NPR formula? N factorial divided by n minus r factorial. So NCR formula is n factorial divided by r factorial into n minus r factorial, right? What is NCR? N factorial divided by r factorial into n minus r factorial, where 0 less than or equal to r less than or equals to n, right? So NCR can also be written as 1 by r factorial into NPR. And we have derived a few other special cases in the combination. If r equals to n, then what will happen? NCN is going to be 1. It is just simple application of the values in the formula. If you are going to take all the n objects at a time, then NCN is going to be 1. Then what is NCN minus r? Again, if you substitute in the formula, we are arriving at NCR. NCN minus r is same as NCR, right? NCN minus r is equals to NCR, which means selecting r objects at a time is same as deleting n minus r objects, right? Then NCR plus NCR minus 1 is equals to n plus 1 CR. These are all the results you should remember which will be used while solving problems, and these results can be easily arrived by simply substituting in the formula for NCR. What is NCR? N factorial divided by r factorial into n minus r factorial. Plus here in the place of r we have r minus 1. So again if you substitute in the formula and after simplification you can easily arrive at this. So what does this imply? If the total number of objects is same. And once you are choosing r objects, and the next if you are choosing r minus 1 objects, and if you want to add, it is nothing but n plus 1 cr. Okay, which means yes, you have to remember, which means we are taking out of n plus 1 objects, we are taking r objects at a time. That's what it says. NCR plus NCR minus 1 is n plus 1 CR. Yes. Next one is NC0. NC0 is 1, which means out of n objects, taking 0 objects at a time, which means we are doing anything there. So it remains as such, which means how many possibilities are there? Only one possibility, to leave it as such. So there are only one possibility. So NC0 is 1. And this is also an important result where we will be using in problems. NCA is equals to NCB. Then A equals to B. Right? Then A equals to B, or else A can be written as N minus B from this result. We know NC N minus R is equals to NCR, right? So A can be written as N minus B. This can be written as what? N minus R. So N minus A or N minus B. B can be written as N minus A, or A can be written as N minus B. So this implies N is A plus B. So far we have seen 5 results. The actual formula, first of all, what is NCR? N factorial divided by R factorial into N minus R factorial. Then NCN is 1 and NC0 is also 1. Then NC N minus R is same as NCR, and NCR plus NCR minus 1 is going to be N plus 1 CR. And if NCA is equals to NCB, if you have the total numbers are same, then A will be equal to B, or else N can be find out by adding A and B. Yes, hope you understood. You have to remember all these results to solve our problems. Now let us solve the problems in exercise 7.3. Now let us see how can we solve our first question in exercise 7.4. It is given if NC8 is equals to NC2, find NC2, right? Immediately what result should strike your mind? Just now we have learnt if NCA is equals to NCB, then N can be written as A plus B, right? So only if we find what is our N, we can find what is NC2. So N can be written as A plus B. So 8 plus 2, which is 10. So once we know what is N, we can very well find what is our NC2 by simply substituting in our formula. N factorial divided by R factorial into N minus R factorial. So 10 factorial divided by 2 factorial into 10 minus 2 factorial, which is going to be 8 factorial, and 10 factorial can be written as 8 factorial into 9 into 10, right? So 8 factorial will get cancelled. 2 factorial is nothing but 2 into 1. So 2 5s are 10, I have cancelled here. So 9 5s are 45. So NC2 is 45. Yes, direct application of the formula. Now let us move on to our second question. Determine N if 2NC3 is to NC3 equals to 12 is to 1. Again, this is going to be a direct application for the formula for NCR, as we did problems of this kind in permutations. So ratios can be expressed as fractions. So 2NC3 divided by NC3 equals to 12 by 1. Right? What is the formula? N factorial divided by R factorial into N minus R factorial. Similarly here, N factorial divided by R factorial into N minus R factorial, which is equals to 12 by 1. Now 2N factorial can be written as 2N minus 3 factorial into 2N minus 2 into 2N minus 1 into 2N. Yes or no? Yes. Right? And similarly, this N factorial can be written as N minus 3 factorial into N minus 2 into N minus 1 into N. That's what we are going to do it here. Before that, since we have fraction, 2 fractions here, when it is division, we need to reciprocate it. So into, this will go to the numerator and this will come to the denominator. So 3 factorial gets cancelled. And as I told you now, 2N factorial can be written as 2N minus 3 factorial into 2n minus 2, 2n minus 1, then 2n. 2n is bigger value, right? So if you reduce 3 values only, you will get 2n minus 3. And similarly here n minus 3 factorial, n factorial can be written as n minus 3 factorial into n minus 2 into n minus 1 into n, which is equals to 12. So these two will get cancelled. So 2n into this divided by n into n minus 1 into n minus 2 equals to 12. n will get cancelled. Again 2, 6 are I have cancelled here. Again from this we can take 2 as common, 2n minus 2. We can take 2 as common. So if we take 2 common, what we will get? 2n minus 1. 2 we have taken it as common, so here we will get n minus 1. Right? So 2 I have taken it as common. So 2n minus 1 into n minus 1 divided by n minus 2 into n minus 1. Again n minus 1 will get cancelled. This 2 and 6 we can cancel out. Then cross multiply this. Then multiply each and every term. 3n into minus 3 2s are 6. Then bring all like terms to one side and simplify it for n. We will get the answer. So this is also mere simplification. Only thing is you should know how can we write this factorial. Right? 2n minus 3 is your smaller value. So 2n can be written as 2n minus 3 factorial into 2n minus 2, 2n minus 1 and 2n. If you know that, you can easily solve the problem. So second subdivision of second question is of same kind. So I am leaving it to you. Do it as homework. Let us see how can we solve the further questions in the exercise. Now our third question is, now find the number of cards that can be drawn through 21 points on a circle. So there is a circle and we have 21 points on the circle. We need to find how many cards can be drawn. What is meant by a card? A card is a line segment passing through 2 points on a circle, right? So if we have 2 points on a circle, then this is a card and this is another card and this is another card, right? A line segment passing who has both the end points on the circumference of the circle is called a card. So the question is, if we have 21 points on a circle, how many cards can be drawn? And if you take these 2 points on the circle and a line segment joining these 2 points will be counted as a single card, even if you are going to take this point as first and this is second, or this is first and this is second. It doesn't matter in which order you are going to choose the point. Anyway, the line segment joining any 2 points is going to be accountable as a single card only. It is not accounted as 2 cards. Right, and hence here we will go for combination and not for permutation. And hence number of cards can be drawn through 21 points on a circle is nothing but 21C2. Why it is 2? Because taken 2 at a time. So out of 21 points, it is taken 2 at a time. Right. So number of required cards is equals to what? 21C2. What is NCR formula? N factorial divided by R factorial into N minus R factorial. So which is equals to 21 factorial divided by 2 factorial. 21 minus 2 is how much? 19 factorial, right? And 21 factorial can be written as 19 factorial into 20 into 21 divided by 2 factorial is 2, only 2 into 1 into 19 factorial. These two will get cancelled, 2 tens are. So the answer is 210. Therefore, 210 cards can be drawn on a circle having 21 points. Okay. Hope you understood. Let us move on to the next question now. See, our next question is, in how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? So they need to select a team of 3 boys and 3 girls from 5 boys and 4 girls. Again, if you see, selecting a boy and a girl in whichever order they form, it is going to be a single team only, right? It is not going to differ if the girl is selected first or the boy is being selected second. So what am I trying to tell you is the order doesn't matter here. So again we are going to combinations. So how can we solve this? A team of 3 boys and 3 girls are to be selected from 5 boys and 4 girls. So first we are going to select 3 boys from 5 boys, right? 3 boys should be selected out of 5 boys. In how many ways? N, C, R. So N is 5. So 5C, 3 ways we can select 3 boys from 5 boys. 3 girls can be selected from 4 girls in how many ways? 4C, 3 ways. So first we can select 3 boys in these many ways and we can select 3 girls in these many ways. But we need a team, right? Therefore by multiplication principle, this will occur first and then this will occur next. So what you should do? These two should be multiplied. So number of ways to select a team is 5C3 multiplied by 4C3. What is 5C3 formula? N factorial divided by R factorial into N minus R factorial. So 5 minus 3 is 2 factorial into 4 factorial divided by R factorial into N minus R factorial. 4 minus 3 is 1 factorial. Right? Now let us simplify this. So if we simplify, 5 factorial can be written as 3 factorial into 4 into 5, 3 factorial into 2, and this is 4 factorial, again it can be written as 3 factorial into 4 divided by 3 factorial. If you simplify, we got 40 as our answer. Thus in 40 ways a team of 3 boys and 3 girls can be selected. Yes, hope you understood. Let us move on to our next question. See the fifth question. Find the number of ways of selecting 9 balls from 6 red balls, 5 white balls and 5 blue balls if each selection consists of 3 balls of each color. So totally we need to select 9 balls, right? And we have red colored, white colored and blue colored balls, and each color we need to select 3 balls, which is also clearly given. So how will you find out? This is easy, right? First we need to select 3 balls out of 6, 3 balls out of 5 and 3 balls out of 5, and we need to multiply all these by multiplication principle. So 3 red balls can be chosen in 6C 3 ways, 5 white balls can be chosen in 5C 3 ways, and 3 blue balls can be chosen in 5C 3 ways. That by multiplication principle you have to multiply all the 3 in order to get the number of ways of selecting 9 balls. Right? I am leaving this problem to you as homework. Let us move on to our sixth question. Determine the number of 5 card combination out of a deck of 52 cards if there is exactly 1 ace in each combination. See, we need to select 5 cards. Out of 5 cards, there should be 1 ace. Right? How many ace cards will be there in a deck of cards? A deck of cards will contain 52 cards. Out of 52 cards, how many ace card will be there? We will be having 4 ace cards. Each ace is of each flower. Right? We will be having, each flower will have 1 ace card. Therefore, there will be 4 ace cards. Right? So every time when we select a 5 card combination, 1 should be an ace. So our first event is selecting an ace card out of 4. So out of 4 objects we need to select 1. So it is going to be 4C1. And then if we remove those 4 cards from 52 cards, how much we will have? 48 cards. So out of 48 cards we have to select the remaining 4 cards. So it is going to be 48C4. So 4C1 multiplied by 48C4 will give you the number of 5 card combinations out of a deck of 52 cards. Yes, hope you understood. Now let us move on to our seventh question. In how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers? This is also the same way as we did our previous problem. In how many ways can one select a cricket team of 11 from 17 players? We have on the whole 17 players in which 11 players they need to select, out of which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers. So our first aim is to select 4 bowlers from these 5 bowlers. There are 5 players can bowl, right? So out of these 5 we need to select 4. So our first aim is going to be 5C4. Then out of 11 we have selected 4. So what is 11 minus 4? It is going to be 7. So remaining 7 players has to be selected from how many? 17 minus 5. 17 minus 5 is going to be 12. So it is going to be 12C7. Yes. See, this is what given in the question. Total number of players is 17. Number of bowlers is 5. So what are the remaining players? 17 minus 5, 12. 12 is the remaining. Right? 12 is the remaining. Now we need to select a team of 11 members. Out of 11, 4 should be bowlers. It is given in the question. So 11 minus 4 is going to be 7. 7 is going to be the remaining players, right? So this 4 should be selected out of this 5 bowlers, and this 7 should be selected out of the remaining players, right? So how will you write this? 5C4. 5C4 multiplied by 12C7. That's all. That will give you the number of ways we can select a cricket team. This is nothing but number of ways of selecting a team. Right? Hope you understood. Yes. So have a clear idea of the question, what is given, and then give your combinations. If you simplify this, you will get your answer. Right? See the 8th question. A bag contains 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. It's easy to solve. I am leaving it to you. The last question, in how many ways can a student choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student? So totally 9 courses are there, out of which a student should select a 5 course program, and out of this 9, 2 specific courses are compulsory. Right? So 5 course, out of that 2 is compulsory. So remaining 3 only optional. And that 3 should be selected out of how many courses? Not 9, because out of 9, 2 is compulsory. So we have to remove the 2, right? So out of 7, 9 minus 2 is 7. So out of that 7 courses, every student should select 3. So it is not. So there are 9 courses. Out of 9 courses, 2 courses compulsory. So remaining 7 courses are there. So on the whole, we need to select, a student should select a 5 course program. Out of 5, 2 is compulsory. So the remaining is 3. So out of 7, 3 courses should be selected, right? Out of 7, 3 courses should be selected. Already 2 is compulsory. So this can be arrived in how many ways? Which is nothing but 7C3, right? So if you find 7C3, that will give your answer, right? Hope you understood. Do these problems as homework. I have given you all the clues to solve the problems. So complete it and post it in the group. If you have doubts, ask me. Thank you, students.